In recent years, a quiet revolution has been unfolding within the field of health and wellness, as scientists and medical professionals turn their attention to the trillions of microorganisms that inhabit the human gut. Known collectively as the gut microbiome, this diverse ecosystem of bacteria, fungi, viruses, and other microorganisms is increasingly being recognized as a key player in determining whether an individual remains healthy or develops disease. The microbiome's influence extends beyond digestion, impacting everything from the immune system to mental health, and even the development of chronic conditions such as autoimmune diseases and neurodegenerative disorders. At the center of this new understanding is a troubling realization. Modern dietary and agricultural practices may be wreaking havoc on this delicate microbial community, leading to long-term health consequences that were scarcely understood just a decade ago. A particularly insidious factor is the widespread use of antibiotics in livestock, especially in the production of beef and chicken. These antibiotic residues, once consumed, can disrupt the balance of gut bacteria, triggering a cascade of health problems that begins in the gut and extends to the farthest reaches of the body. The gut's gatekeeper role. To appreciate the significance of the gut microbiome, it is essential to first understand its basic functions. The gut is not merely a digestive organ. It serves as a complex interface between the outside world and the body's internal environment. Everything consumed, whether food, drink, or medicine, passes through the digestive tract, where it interacts with the microbiome. In a healthy state, the microbiome helps break down food, absorb nutrients, and produce essential compounds such as vitamins and short-chain fatty acids, which support immune function and regulate inflammation. But the microbiome is more than just a passive player in digestion. It actively communicates with the immune system, serving as a gatekeeper that decides which substances are allowed to pass into the bloodstream. A balanced microbiome promotes a strong, well-regulated immune response, protecting the body from harmful pathogens. However, when the microbiome is disrupted, a state known as dysbiosis, this protective barrier begins to break down. The result is a leaky gut, a condition in which the intestinal lining becomes permeable, allowing proteins, toxins, and bacteria to enter the bloodstream. The concept of dysbiosis is central to understanding the microbiome's role in health and disease. Dysbiosis occurs when the delicate balance between beneficial and harmful bacteria is disrupted, often due to external factors such as diet, medication, or environmental toxins. Antibiotic residues in food, particularly in beef and chicken, have emerged as a major culprit. These residues can survive the cooking process and, once ingested, disrupt the balance of gut bacteria. The problem is not limited to antibiotics administered during illness. In many industrial farming operations, livestock are routinely given antibiotics to promote growth and prevent infections in crowded conditions. When antibiotics enter the human gut, they do not discriminate between harmful bacteria and beneficial species. As a result, the diversity of the gut microbiome diminishes, and harmful bacteria are given the opportunity to proliferate. This shift in bacterial composition sets off a chain reaction. Harmful bacteria release toxins that irritate the gut lining, leading to inflammation. Over time, this inflammation weakens the intestinal barrier, resulting in leaky gut syndrome. In a state of leaky gut, the normally tight junctions between intestinal cells loosen, allowing undigested food particles, toxins, and bacteria to slip through the intestinal wall and enter the bloodstream. Once in the bloodstream, these foreign substances can provoke an immune response. The immune system, in its attempt to neutralize the perceived threat, begins producing antibodies not only against the foreign invaders, but also against the body's own cells. This is the mechanism by which autoimmune diseases develop. Autoimmune diseases, once considered rare, are now on the rise, and dysbiosis and leaky gut syndrome are increasingly being implicated as contributing factors. Conditions such as lupus, rheumatoid arthritis, and Hashimoto's thyroiditis are all linked to an overactive immune response in which the body attacks its own tissues. In the past, these conditions were often seen as isolated phenomena with unclear causes. Today, researchers are beginning to connect the dots, recognizing that gut health may be a critical factor in the development of these chronic conditions. The autoimmune response triggered by dysbiosis is complex and multifaceted. As the immune system becomes hyperreactive, it produces inflammatory cytokines that circulate throughout the body, contributing to systemic inflammation. In the case of rheumatoid arthritis, for example, these cytokines target the joints, causing pain, swelling, and eventual joint destruction. In lupus, the immune system attacks multiple organs, including the skin, kidneys, and heart. Hashimoto's thyroiditis, an autoimmune condition that affects the thyroid gland, leads to hypothyroidism and a host of related symptoms such as fatigue, weight gain, and depression. While autoimmune diseases are notoriously difficult to treat, there is growing interest in targeting the gut microbiome as a potential therapeutic avenue. Early studies suggest that restoring microbial balance through diet, probiotics, and lifestyle changes may help alleviate symptoms and reduce the frequency of autoimmune flare-ups. However, much of this research is still in its infancy, and further studies are needed to fully understand the relationship between the microbiome and autoimmune disease. As if the connection between gut health and autoimmune disease weren't complex enough, there is also mounting evidence that dysbiosis can affect the brain. This is due to the gut-brain axis, a bidirectional communication network that links the gut and the central nervous system. Through this axis, gut bacteria can influence brain function, mood, and even the development of neurodegenerative diseases. In the context of dysbiosis, the breakdown of the gut lining can have profound effects on the brain. Just as the gut becomes leaky, allowing harmful substances to enter the bloodstream, the blood-brain barrier, another protective barrier, can also become compromised. When this happens, inflammatory molecules from the gut can cross into the brain, where they disrupt the delicate balance of neurotransmitters and hormones. This can lead to a wide range of neurological symptoms, including anxiety, depression, and cognitive decline. Researchers are also investigating the link between dysbiosis and more severe neurological conditions such as Parkinson's disease and Alzheimer's disease. In Parkinson's, for example, it has been observed that gut bacteria may play a role in the misfolding of proteins in the brain, a hallmark of the disease. In Alzheimer's, chronic inflammation and immune dysregulation, both of which can be influenced by gut health, are thought to contribute to the accumulation of amyloid plaques in the brain. Given the far-reaching effects of dysbiosis, many experts are advocating for a proactive approach to gut health. One of the most effective ways to support the microbiome is through the use of probiotics, live bacteria that can help restore balance to the gut ecosystem. Probiotic supplements typically contain billions of colony-forming units, CFUs, of beneficial bacteria, which can help replenish depleted microbial populations and reduce inflammation. However, not all probiotics are created equal. The effectiveness of a probiotic depends on several factors, including the strain of bacteria, the dosage, and the individual's specific gut environment. For this reason, it is recommended to take a high-quality probiotic with a diverse range of bacterial strains. A daily dose of 60 to 80 billion CFUs is often suggested for those looking to support their gut health. In addition to probiotics, dietary changes are crucial for maintaining a healthy microbiome. Fiber-rich foods, such as fruits, vegetables, and whole grains, provide the necessary fuel for beneficial bacteria, allowing them to thrive. Organic produce is especially important, as it reduces exposure to pesticides and chemicals that can further disrupt the gut. Equally important is the need to avoid sugar and processed foods, both of which can feed harmful bacteria and contribute to dysbiosis. As research into the gut microbiome continues to evolve, it is becoming increasingly clear that this complex microbial community plays a central role in determining our overall health. The implications are vast. From autoimmune diseases to mental health disorders and beyond, the microbiome may hold the key to understanding and preventing a wide range of chronic conditions. For individuals, the takeaway is simple yet profound. Maintaining a healthy gut is not just about digestion. It is about preserving the integrity of the body's immune system, protecting the brain, and reducing the risk of chronic disease. The microbiome is the silent architect of health, and by nurturing it through probiotics, a balanced diet, and mindful lifestyle choices, we can unlock the potential for long-lasting wellness. And that wraps up our deep dive into the critical role of the gut microbiome in shaping our overall health. From autoimmune diseases to brain health, it's clear that the balance of bacteria in our gut can be the difference between wellness and disease. So, if you're ready to take control of your health, consider incorporating probiotics, fiber-rich foods, and organic produce into your routine, while cutting out sugar and processed foods. Don't forget, what you eat today can have lasting effects on your future well-being. Thanks for watching. If you found this video helpful, hit the like button, share it with others, and subscribe for more health and wellness insights. See you next time.